Hello and welcome to the webinar on CalMAN 2016. Today we have Joel Barsotti, who's the head of advanced color research.
Hi everyone.
And Tyler Pruitt, who's the technical liaison for CalMAN products.
Hello.
And myself, Josh Palmer. I'm in charge of sales and marketing. Today we'll be talking about new features and new hardware integration that's supported in CalMAN 2016 mainly. And at the end, there will be a Q&A session towards the end. So if you have any specific questions for Tyler or Joel, you can submit them at spectracal.com/webinar, and we will be fielding questions towards the end of the webinar. So the first item that we want to talk about is the new features that are in CalMAN 2016. So Tyler, do you want to start off with that?
Yeah, so we've already made some videos on them on our YouTube page if you want to see an in-depth tutorial on how to use these features. I'll just start at the top. We have something called our full field pattern insertion. And this is intended for use on LG OLED televisions, where when they have window patterns up, when you're taking measurements, even if the colors of the patterns are changing, the TV assumes that it's a static image because the window pattern is still the same size, even though the color is changing. And after about 1 minute and 15 seconds, it starts to dim itself down about 1 nit every second. And this can really affect your calibration and measurements because it happens so slow you don't really realize that your changes are being affected by this dimming behavior. And the TV is doing it to protect itself from burn-in or image retention and stuff like that. So we came up with a solution where we would inject a full field pattern every specific amount of time that you can set, and that defeats that behavior, or it resets the clock of that behavior. So this is a nice feature if you're just doing a manual calibration, but it's a absolutely essential and required feature to get good results if you're doing a 3D LUT calibration.
And I just want to add to that too, that one of the reasons that we put that feature in there is because the LG OLEDs are becoming kind of popular on a studio level for client.
Yeah, so the 2016 LG OLED is looking like the new client monitor in Hollywood. So we really needed a solution for that problem because it was popping up over and over, and we were having to explain that you have to put up a different pattern, whether it be like a brightness pattern to reset that. But now we have an automated way of CalMAN just keeping track of how long it's been since we've put one of those full screen patterns up, and it will automatically do that. The next thing is we've added the JUD modified white point for RGB OLED broadcast monitors. This is so they perceptually match other display technologies closer. You previously had to manually enter a custom white point in CalMAN. Now it's just a preset white point target. So if you go into any workflow and you're in the target setup page, under white point where it'll default to D65, you can click that drop down, and now there's one, so you can do the JUD modified white point. The next thing would be the HDR10 workflow. Now it's currently, I consider it like a public beta because of the vast different behaviors and calibration controls that the different TV manufacturers are disabling or enabling, or the behavior is different from manufacturer to manufacturer. So the HDR10 workflow has been released, but we're going to be continually adding and reconfiguring it, adding more instructions for specific display manufacturers. And also with that, we made a new home HDR report. Because the existing home report and any other report don't have their charts and graphs properly set up for HDR. So we added this new home HDR report so you can have a nice report if you measure or calibrate your HDR10 TV. Another feature of the home HDR report is the reason it's not called the home HDR10 report is because it's also compatible with the Dolby Vision workflow. There is a Dolby Vision report, but that's only available to professional users. It's intended to be used by pro calibrators, and it has the before and after and all the information of the calibrator and what devices were used. But we wanted to make a report that home users of the Dolby Vision workflow could also have their own report. So we made it so it's compatible with both the HDR10 workflow and the Dolby Vision workflow. Relating to the Dolby Vision calibration is now we support in CalMAN 2016 the Dolby Vision Golden Reference File import. And Joel, do you want to talk a little bit about what that is?
Oh, sure. It's a specific file format that we implemented to be, from Dolby, so that we can rapidly expand the number of supported displays. The really cool thing about Dolby Vision is that each manufacturer goes through Dolby's labs and they're able to come up with a golden reference for exactly the way the display should perform. So what its gamut volume should be, how much the peak output is. And so once they run all that data through their algorithms, they're able to create a map of the color space inside Dolby Vision. And so previously we were gated on our ability to distribute those by having them included inside CalMAN. Now with our ability to support external file formats, manufacturers or Dolby can provide those as rapidly as the displays are delivered to the field, and we're not stuck waiting for the next release of CalMAN in order to get those out.
Yeah, and I think that's a big deal when we start getting more and more TVs, including when they start releasing Dolby Vision to lower and lower models that are, they have a lot more of those models than their very high-end TVs. So you won't have to wait for us to release something to import your targets. And the manufacturers, along with Dolby, work together to release those files. So Vizio has posted them for the P series. I know LG and Dolby are still working on the ones for the LG OLEDs and their LED-based Dolby Vision TVs. So look out for those, and I'm sure they'll be in the AVS threads of the TV models. The next thing I want to talk about, and I actually have a slide for it, is we have this new feature where inside of a Rec 2020 color space target, this is mainly intended for HDR10, we can actually do DCI P3 sweeps, saturation sweeps, or Rec 709 sweeps. Do you want to talk a little bit about how that works, Joel?
Sure. And so the reason that we're doing this is that all content that's being delivered on UHD Blu-ray for HDR is all Rec 2020 color. And so what this means is that, the individual colors have, specific chromaticities for, Rec 709 red versus DCI red versus 2020 red. And so RGB colors and YCC colors are what we call relative, like fully saturated 100% red, 0% green, 0% blue isn't actually a color until it's paired with a matching gamut, whether it's Rec 709 or Rec 601 or whichever standard it is. And so the standard for delivering content on the new Blu-rays is 2020. So all color on those discs is described as 2020 color. Now, obviously, the displays can't reproduce the full gamut for BT 2020. So the question then becomes, well, how can we quantify the performance of the display against the DCI gamut or against the 709 gamut? And so I believe what we're looking at now is the DCI gamut laid inside of the 2020 gamut. And so you can see that, for instance, the red triplet, and I believe that this is based off of an HDR level. So you can see that the triplet, though, is significantly desaturated. It says, if you look down underneath where the gamut is, you can see the RGB triplet. And so what would be the equivalent of about 100% red and 100 lumen standard SDR 100 luminance display, you end up with an RGB triplet of 120, 168, 16. So there's no blue in it because it's right there at the edge of the gamut, but there's actually a significant amount of green that's added into the color description to describe where DCI lands in Rec 2020. Now, obviously, as it goes through the processing pipeline in the display, it should know how to convert 2020 to its internal gamut, which may end up being, close to the native red. But by being able to select this, you're able to stress the whole processing pipeline of the display, from its YCC to RGB conversion, and then its RGB conversion from 2020 to the display's native capabilities. And so this allows us to really accurately characterize how a display can handle these new wide color gamuts while still remaining accurate for the parts of the image that are important for us, like flesh tones and things that are much more desaturated than the laser primary edges.
Yes. So also, like Joel said, 2020 is the color space for home HDR. There's no such thing as home P3 color space. In fact, in the metadata for HDR10, when people say that the mastering display says P3, there's no flag that says I'm P3. It's actually just XY coordinates for the red, green, and blue. So the mastering display can be anything from the 2020 size down to 709 and still be valid, to something in between. Like if you mastered something on the Sony X300 in 2020 mode, it would be slightly bigger than P3, and you wouldn't want to put P3, or you wouldn't want to put 2020 as the primary. You would want to measure its maximum gamut and put those in your metadata. So yeah, no matter what it says in the metadata, it's always being signaled as 2020, and the display used the metadata to know what the maximum gamut of the content is for its remapping algorithms.
And that's been a pretty big misconception in the last few months of what do I calibrate to, either P3 or BT 2020.
And so also people are like, we can't hit 2020. Well, so that's why we recommend measuring your accuracy at a lower saturation rate, or running a saturation sweep. And you'll see that a lot of displays can't cover this full P3, so they can cover like 90% of it, but it should track correctly through the saturations until it has to compress the edge of the gamut. It shouldn't have the whole gamut compressed in, because then all your colors in the middle of the gamut will all be desaturated. Mm-hmm. So next is some new hardware support. So this is going to be a very long list because we've been working on CalMAN 2016 for a while, and we've been adding a ton of new hardware support. So the first one is the Teradek Color LUT box. It's a 33-point LUT box that has SDI in and out and HDMI in and out, and you can cross convert. It's really small. I think it's going to be popular for client monitors and like in Video Village and stuff like that on set. It has a built-in pattern generator. It has Ethernet, Wi-Fi, or USB Ethernet connections to CalMAN. It doesn't support HDCP, so you can't use it as a home theater device. But for any other HDMI-related thing that's not HDCP required, it works great. The next thing is the HD Fury Integral 4K 60. Now, this is a little box that can inject HDR10 and BT 2020 metadata into an HDMI stream of another device. So what this allows you to do is take your existing pattern generator and turn it into an HDR10 pattern generator without having to buy a new pattern generator. We have tutorial videos on both of those on our YouTube page that goes more into depth, walking you through how it works. We've added support for new ASO monitors, the 318 4K and the 248 4K monitors. We're using their new extended LUT interface. Now, the cool thing is it allows us to overwrite the factory presets. So on previous ASO models, we would only be able to calibrate the cal modes, and there was only one of those per input. Now we can overwrite the built-in color spaces like Rec 709 or sRGB or Adobe or DCI-P3. So you have a lot more options for calibrations. The one downside of us using this extended LUT interface that they've added is you have to use an external pattern generator, whether it be something like Virtual Forge, or if you're using this as a graphics monitor, something like Client 3. You can't use their internal pattern generator. Another feature we've added is we've added an Atomos.cube format for our cube generator, and this allows you to create a calibration 3D LUT for the Atomos Ninja Assassin, Shogun, Shogun Flame, and Shogun Inferno recorder / monitors. So we can spit out the cube file, you load it, you put it on the SSD or hard drive that goes in it, and then you can load it. That we also did a video on our YouTube page for that. The next thing is the new Panasonic DX900 and DX800 series. Now this applies to the European and US models. We have AutoCal support in them. Just like all the other previous years of the Panasonic high-ends, we have AutoCal for the CMS and grayscale and gamma. One thing to note is the new Panasonic DX900 and DX800 use a new LED type called PFS phosphor. It's a new red phosphor mix. If you looked at it with a spectroradiometer, the spectrum has 3 big spikes in red instead of one red hump or one red spike. It allows them to do a really wide color gamut. But we have added that as a new meter mode to the C6. So we're already ready to calibrate those with the new EDR or meter mode in the C6. And also AZO is using that same PFS phosphor technology in their 318 and 248 models that we just added. Another device that we've added support is the Quantum Data 980. This is a really high-end pattern generator. It's used a lot in manufacturing and R&D. But we've added support for BT 2020, HDR10, and all existing SDR pattern support. On the topic of BT 2020 support, for the Quantum Data 780 and 804, we've added BT 2020 AVI info frame support. So on certain HDR displays, if they don't see BT 2020 signaling and HDR metadata, they will not go into HDR mode properly, or they'll go into HDR mode, but they'll be using a 709 gamut. So certain manufacturers, they require you to send BT 2020 signaling to properly go into HDR mode. So we've added that to the Quantum Data 780 and 804. Another thing that's kind of related to the Teradek color is something called the Off Hollywood O-Mod. This is an accessory for the new Red Weapon cameras. And it essentially has a Teradek color inside of it. So it can support 3D LUTs, and CalMAN can also use it as a pattern generator. And how you would use this is if you were to have this on set, you could connect to the O-Mod and use it as a pattern generator for all the Video Village or downstream monitors to check them. And then you'd be actually going through the same video pipeline that the camera was actually feeding out of. So that is a lot of the new hardware. One last thing is the Meridio 6G pattern generator with their latest firmware. We've added BT 2020 support, and we're also working with them on Dolby Vision support. So that's going to be the first pattern generator that supports Dolby Vision. So that's our new hardware support for CalMAN 2016. I think we're ready for our Q&A session.
Yeah, and before we get to the Q&A, I just want to mention a special that we have going until the end of July. It's our 4K HDR bundle. It comes with CalMAN Studio, Meridio 6G pattern generator, which can send the HDR10 metadata that we were talking about earlier, as well as output 4K pattern sizes. And it also comes with the SpectraCal C6 HDR. So that's a discounted price going through the end of July. If you want to learn more about that promo, you can go to our homepage, click the banner at the top, and then the promo will be at the middle of the webpage. So now we can get into the Q&A session. We already have some questions, it looks like, coming in. So if you want to take the...
Okay, so the first question is, I'm looking to switch from Lightspace to CalMAN. Would I be able to use my OEM I1 display probe that I bought with Lightspace? And the answer is yes. The OEM probes can work with any OEM software. They're not locked to any one software. So that's a big yes. So pretty much any version of CalMAN, you can use that meter. The next one is, I have a CalMAN enthusiast license and typically do my 1080p TVs with Mobile Forge. Now I have a Sony X850D, which has HDR10 capability. Am I good doing the above setup on this TV without incorporating HDR? So you can just calibrate the SDR, but if you want to do HDR, probably the easiest way it would be to add an HD Fury integral into the pipeline, and then you could signal the HDR metadata in BT 2020.
And can you talk a little bit about how that is actually configured? Because I think it can be a little confusing about what in the chain kind of what.
So you would have your existing pattern generator going into the HD Fury, and then its output would go into the TV, and then there's their software that runs on your PC that it has places for you to enter these hex strings of metadata. Now, CalMAN can generate those hex strings for you. We have a video on our YouTube page that walks you through the process. It's a little bit, it's not complicated. It's just easier to explain it when you can actually see the fields.
Yeah, it sounds.
So pretty much, you configure the metadata, and then you copy and paste 2 strings into the HD Fury software, and then it injects the metadata.
In terms of CalMAN, though, you're connecting to the HD Fury, correct?
Well, no. If you want to save the step of copy and pasting, you can buy separate software called AV Top software that can talk to the HD Fury directly, and CalMAN can talk directly to that. Or you can connect to the AV Top setting in or source device in CalMAN, and then if you don't have the software, it'll still generate those strings for you. But it's not actually connecting directly to the HD Fury. It's just generating the strings for you. Like I said, check out our YouTube page. There's a tutorial on that. The next question is, how can I minimize banding on a LG 10-bit OLED monitor using a LUT? So they have some native inherent banding in them. So you can't really use a LUT to minimize something that's native in the panel. It's not terrible, and if you are using a LUT, you probably want to pick the closest gamma to your target, so you're not making large adjustments in that, adding extra banding to it. So that's just.
Yeah, I mean, it's one of those things. If the display has banding, it's because the display itself can't produce fine enough gradation. The individual steps between one signal level and the next signal level up changes the luminance so much that you see a distinct difference. What you really want in a display is that for each step, it's actually below the visible threshold, so that you can't see the difference between one step and the next. So, if it's getting brighter too fast, then the only way you would be able to compensate for that would be to actually just, effectively target, there's just really not any way that you can sort that out. However you would modify the signal, you'd end up with, having that same jump in luminance from one signal step to the next, and throwing a LUT on top of it to try and manipulate it really can't make it better. There's only really a possibility to make it more perceptible with that.
Thanks. So the fourth question kind of is on the same as one of the earlier questions. Is there a low-cost way of calibrating HDR10 without needing an expensive generator? So if you have something like Mobile Forge, or you have a known properly configured HDMI output of your computer, you've checked it against some other reference signal, and you know that the bit levels are correct, then you could just connect that through an HD Fury to inject the metadata. The next one is, how appropriate is CalMAN's technology and measurement devices for measuring laser illuminated projectors? So Well, first let's talk about, there's two different types of laser projectors. One is called laser phosphor, where they use a blue laser they use the blue laser energy to create the blue energy, and then they shoot the laser onto a phosphor wheel that creates the red and green energy, kind of like how a blue LED can excite a phosphor and create a white LED. So on those technologies, the laser phosphor technology, the spectrum of the light actually really resembles blue LED, white LED. If you want a better, more accurate measurement, you can create your own with create your own matrix offset table with CalMAN and a spectroradiometer. We are currently in the process of adding an EDR to the C6 for laser phosphor. The other technology for laser projectors is RGB lasers, which is mainly used in really high-end projectors and digital cinema projectors like the Barco and Christie laser projectors. So those you would definitely need a spectroradiometer because they have very narrow band spectrum. The next one would be calibrating HDR10, calibrating BT20, including P3 for the UHD premium standard. What should we do with saturation levels? I think we kind of talked about that when we showed you the P3 sweeps, is don't just measure the gamut at one point, do saturation sweeps. It's still applied to SDR as well. You could get the edge of the gamut perfect, and then you do a saturation sweep and it would be way off. And most of the content is in the middle of the gamut, not at the edges. So I almost always check my calibration or look at a sweep of the saturation points when doing a calibration of the color gamut. The next one is, based on looking at the Dolby Vision workflow, it seems the recommended pattern source is the built-in pattern window output of a laptop's HDMI port. I have always used professional pattern generators. This concerns me. Since the output of HDMI ports varies from computer to computer, differences between Intel and NVIDIA, how does CalMAN compensate for these settings? Do you want to talk about that, Joel?
Yeah, I mean, so I read that question and sort of the first thing that came off the top of my head is that CalMAN doesn't actually. The thing with Dolby Vision is that the specific way that the metadata is encoded into the image, if it's wrong, it just won't work. It won't go into Dolby Vision. It won't turn on at all. And so if, one bit steps out of line, this process falls apart. And so by being able to view the Dolby Vision test image that's embedded in CalMAN, if that image works and correctly sets the TV into HDR mode, then you have perfect bit accurate output.
And that's something that we've tested with.
Oh yeah,
hardware.
no, we've not only have we worked closely with Dolby to get that working. We ran the laptops that we saw correct functionality through quantum data analyzers to see what was actually going on the wire. These are things that we know have been validated in-house through multiple levels of technical scrutiny. And then in terms of being able to configure those graphics cards, I believe we've got a quick start guide on that up on the website that Tyler wrote that walks you through all the specific settings. And the person who asked the question is right, that there are a lot of settings and they can change depending on whether or not you plug it into this TV or that TV and how the EDID handshakes. The truth is that for most modern graphics cards with current drivers, if you set everything up for neutral, the RGB color will be exactly where it's supposed to be, and the YCBCR conversions are really spot on. So it gets down to being just issues with levels and then whether or not things have a little bit of dithering. There aren't generally large errors in the output of graphics cards, but they can also be easily misconfigured, that there's an ability to go into like an NVIDIA and turn on digital color vibrance, or play with a brightness slider or a color slider in the settings and make them wrong. So there's a lot of opportunity with a PC graphics card to screw the output up. And there's a lot of handshake issues, so you need to be cognizant of whether or not your black level is correct coming out of the card compared to what the TV is expecting. But
that applies more to SDR, right? With Dolby Vision, if it doesn't go into Dolby Vision mode, then if it doesn't go into Dolby Vision mode, then it's wrong. If it does, then you know it's bit perfect accurate, because if there's any conversions or scaling or DPI scaling or color adjustments, then the metadata will be screwed up and the TV won't go into Dolby Vision mode. So once you know that you can get it into Dolby Vision mode, you know your output is bit perfect.
Yep, absolutely.
The next one I have a slide for. Somebody was asking, understanding the grayscale dip in HDR. So I think what they're referring to is this. Oh, whoops, wrong screen. They're referring to is this. So this is our EOTF graph. This is ST2084. If the gray line is below it, that means it's under luminance. If it's above it, it's over luminance. Now, at the very top, they have to roll off the highlights because they don't want it to hard clip. And this is the highlights rolling off. So you just want to make sure your display is following ST2084 as close as possible before the highlight roll off starts. So we're over luminance right here on this particular display. We would want this at 0 until it starts going down on the highlight roll off. Do you want to add anything to that, Joel?
No, I mean, that's pretty much exactly what's happening. You know, we're able to determine what the peak luminance is, and so we know that from the point where it starts clipping through the end, you know, what that should be. And so you can see there that, you know, on the graph that we're looking at above, whatever that is, about bit level 190, you know, we track the luminance, you know, accurately compared to what the display is doing. The display is doing the right thing. And then there's that roll off, which is, you know, the display trying to be able to show more code values in between where it can hang on to the SMPTE-2084 EOTF and where it hits its peak luminance. And, you know, that's what we need to be able to display content that was, you know, mastered on a 1000 nit display, but we've got a display that can only produce, you know, 600 nits. And so we have to figure out how to, you know, take that highlight range and get it down so that it fits inside the capability of the display. And hopefully in some future version of CalMAN where this is a standardized, we'll be able to model that roll off and we'll be able to show you a better graph of, you know, this following the standard. But as there is no standard right now, all we can do is show you the performance of the display relative to a pure 2084 transfer function. And so that way, for now, it's appropriate to see this dip as we roll the highlights off.
Okay. The next one is, are the base level meters like the i1 Display Pro capable of calibrating HDR? And the answer is yes. The i1 Display Pro is rated up to 1000 nits. So for most of the current HDR TVs, it's fine. Our C6 HDR, each one is tested in our lab to be accurate up to 1300 nits. So we're also constantly talking to measurement device manufacturers to say, you know, the TVs are going to have to get brighter every year because that's for marketing purposes.
It's kind of about future proofing.
Yeah. So eventually we're going to have even meters that can support 2000 nits, 4000 nits that don't cost $4,000 or $6,000. Yeah. You should be good right now with the i1 Display Pro. The next one is, can we have support for ISO CG 2420? We work very close with ISO, so those models just came out, so we're working with them on the new SDK that has support for those. Now that we finished doing the 318 and 248, I'm sure those will be in the pipeline. The second part of that question is about a 1D monitor calibration, 1D LUT monitor calibration solution for Linux. And we did show a little preview of that technology at NAB in our booth. Do you want to talk a little bit about it, Joel?
Yeah, sure. And so, they also mentioned a full version of CalMAN for Linux, and that's something that, has been discussed, but not anything we're planning. But in terms of, calibrating Linux desktops, it is something that we're looking into. And the prototype that we showed at NAB this year was a little app that could talk to a meter and perform a self-calibration on a Linux desktop, and was able to interact with the AMD driver for the graphics card to actually do not just the LUT correction, but also calibrate the gamut and generate an ICC profile and register with the operating system. So that's a pretty cool little piece of technology that we have. We're not entirely sure exactly how we're going to bring that to market, but it is things that are happening here in our development labs. So, stay tuned for more. Hopefully we'll have ever expanding operating support coming from SpectraCal in the near future. And it looks like the next question that we have was that given that there are no currently available consumer displays, much less Dolby Pulsar that can, do 10,000 nits of the 2084 standard, hasn't it made much more difficult to measure and ascertain the accuracy of the display's EOTF? Not really. I mean, the 2084 standard was based on 10,000 nits, based on, what they thought we were going to be able to accomplish in the near future, meaning, 5 years to 10 years out, sort of. Because if you look at the lifespan of standards, you can kind of see that that's sort of a typical lifespan. So, how long was HD around before 4K started to supplant it? How long is, the HDR going to be around in its first, real version before it's supplanted by something else? And if you look at, what people are able to do with research and prototypes, they're already well past what they were doing with the Pulsar. The Pulsar is technology that's, 3 or 4 years old at this point. So I think we can expect that technology like that's going to come to market more rapidly. I mean, the one thing with designing a standard that is a little bit future-proof to like 2084 is that, now we have the situation where we need to handle gamut mapping and, highlight tone mapping for the highlights. And so this certainly does make for a more complicated situation than traditional calibration. But it's not something that you need to be afraid of or fearful of. And, as of right now, none of the display manufacturers give you control over the way that tone mapping happens. But, as we saw in the graph a few moments ago, it's something that happens right at the end of the display, and it's something that's handled internally by the display. But up until the point where the display rolls off, you can very easily and accurately calibrate the display to follow 2084 right up until that point. And then in the future, when display manufacturers give us control over that, and we have a spec for what that standard should be and how that roll-off should work, it'll be implemented and those controls will be given to you. And so we'll just continue to make things even more accurate, more to standard, so that everyone's able to get, that same quintessential experience of what the people got when they mastered the content on HDR displays to begin with.
And also, like content that's currently being mastered at 4,000 nits, you'll be able to get, as you get a new TV, say in 3 years you get one that does 4,000 nits, you'll be, the content is already mastered for that. Right now you're not seeing the full benefit of that, and they won't have to re-release the content. Like if they released one now, obviously some of them they're only doing to 1,000 nits, but a lot of the stuff that is being released at 4,000 nits right now you're kind of future-proof for a little bit. And the standard itself is future-proof up to 10,000 nits. And that's why, even though we're using only like 70% of Rec 2020 right now, that doesn't mean we can't use the full gamut volume in the future, and we won't have to come up with a new standard.
And the other great thing about it as well is that when we get TVs that do 5,000 nits and maybe, 2 to 3 years out, we'll be able to go back and watch content that was mastered on a pulsar and be able to see all of the content, the full luminance range and the full gamut that we're getting out of.
And it'll probably look better than the mastering person was looking at, because the pulsar is only 1920 by 1080. So you're actually probably going to get a better experience in 2 years than the people that mastered the movie. So we're really excited about that. The last question was, I had to make a custom Judd white point for Sony OLED based on Sony's white paper using the Klein K10 to the chromaticity targets are X 0.311, Y 0.318. Well, the 1931 XY coordinates for Sony's offset is actually X 0.3067, Y 0.318. So you might have, in that white paper, they have a lot of different chromaticity targets because of the way they first measured the displays with the Judd-Voss color matching function, and then they adjusted the OLED with that, and then they remeasured it with 1931 and got it separated. So there's a lot of XY coordinates in there, so you might have just got that confused.
Like we mentioned earlier, that's in the newer release of CalMAN 2016 preset, so you shouldn't even have to enter it in now.
Right. And the other thing is with the offsets as well is, that was Sony's experiment that they ran internally with their original OLED and their BVM, their CRT BVM that they had at the time. And so I believe in the field, people now that they're using the X300, which has a slightly wider gamut than the original Sony OLEDs, are now seeing that things may need a slightly different offset for that one as well. And so, the best thing you can do is if you actually have a spectrophotometer on hand to actually recreate Sony's experiment and measure the display that you're trying to match. Or the other option is that inside CalMAN, if you go and look where you can use alternate color matching functions, we do provide reference numbers for if you were to take a theoretical D65 light from the sun, how that would measure, and you can use those targets as well. So there's a lot of different options, and if you just have a colorimeter on hand, then as Tyler mentioned, we have the Judd-Voss numbers baked into CalMAN now, so you don't need to go find them.
It sounds like it'd be a good tutorial video for us to do, showing them how to use the alternative color matching functions. So we'll have to put that on the list, and stay tuned on our YouTube video for that.
So that concludes our webinar on CalMAN 2016. Feel free to subscribe to our YouTube channel to see future videos that come out. This webinar will also be posted on our YouTube channel, so stay tuned for that. And thank you for watching.